Now that we have a good understanding of the different layers of the atmosphere, let's look at what happens once heat enters the atmosphere. So when we're looking at heat, we're simply looking at energy. And you'll notice that I have up here a capital E. This is my abbreviation for energy. So if you ever see in my notes that I have a word and then in parentheses next to it I have all caps, a couple letters, that's my abbreviation for it, so that way I could take notes faster, or you could write down notes faster as well. So if you would like to adopt that, you are, by all means, may do that. So heat is energy. We have heat transfer because there's a direct difference in temperature. If you touch your desk, okay, the desk may feel cold to you or may feel hot to you. But you're going to have a transfer of energy because the desk and your hand are going to be two different temperatures. When we're looking at temperatures, we're simply looking at the amount of heat that is there. So if something is really, really hot, obviously that means there is more heat, which you could also say that object has more energy. And if something is really cold, there's less heat, or you could even say that object has less energy. So heat is just energy. That's another way to look at it, especially when you get to chemistry. You're going to look at that a lot. And think about it. What is our main heat source for the earth? Our main heat source is the sun. Well, that also is our main energy source. So the two do go together. I'm going to give you another second to finish writing this slide down. Remember that instead of writing temperature, you can just write temp. Any type of abbreviation like that to make you write notes faster. So just one more second. So moving right along, let's look at types of heat transfer. Well, before we do that, think, pair, share. If you put your hand in a bucket of ice, does the heat from your hand go to the ice, or does the coldness from the ice go to your hand? You can only pick one. Okay, if you said that the heat from your hand goes into the ice, then you are correct. Heat transfer happens from hot to cold objects. So make sure you do write down that bottom bullet. So again, if you touch your desk, if the desk is feeling cold to you, that is because the desk is warmer than what your hand is, and it's taking the heat out of your hand. So if you put your hand on the desk, I think I said that backwards. The desk is colder than what your hand is, and so therefore it's taking the heat out of your hand. So anytime you touch something and it feels cold, that feeling that you're feeling within your hand is the heat literally leaving your hand. It's stealing some of that heat from you. That heat transfer is occurring. So heat always goes from hot to cold. You could almost think of it as there's no such thing as like really something being cold. It is simply the absence of heat. Anytime something is cold, that's because it is lacking heat. So we are simply measuring in temperature how much heat there is. Is there a lot of heat, or is there pretty much no heat there? But that is what we are measuring. So heat goes from hot to cold. Now we're going to look at a few ways that this heat transfer actually occurs. So there are a couple of demos that I usually do, but I'm not able to do that with you since I'm not there. So I'm going to show you some videos of some cool demos too. So the first heat transfer method we're going to look at is conduction. Conduction is the transfer of heat through touch. So if you were to put your hand in a bucket of ice, you're touching the ice, and therefore the heat transfer method is conduction. When you touch your desk, because you're touching your desk, that is conduction. If you've ever eaten soup or stirred a cup of hot chocolate and left the spoon in there for a while, whenever you go pick up the spoon, sometimes it can be very hot, and that's because if the spoon was touching that metal, you have conduction going on, and that is going to transfer the heat through direct touch. So anytime something is touching, it's conduction. It has to be a direct touch, direct contact in order to be considered conduction. Sometimes you hear like metal is a good conductor. That's why a lot of our cooking pans are metal pans. That's because as they touch the heat source, they transfer the heat very quickly, very easily. That's why if you put a skillet on the eye, that skillet, the bottom of the skillet will get warm very fast. Versus if it's made of another material, it might take it a while longer. So that's our first heat transfer method. Our second heat transfer method is convection. Convection is the transfer of heat by circulation. So convection currents occur in fluids. I want you to imagine that you have a candle, or a fire. So we'll draw a little candle. Here's my flame. Okay. The air directly around the flame of that candle is going to be warmed up. Well, what do you know about what happens to warm air? Well, warm air rises. So the air that's being warmed by this flame is going to rise up. As that air gets away from the heat source, it's going to cool down. And as it cools, it's going to go back down. That air is then going to get warm again and continue to go up, where once it gets away from the heat source, it will cool off and then it will go back down. So you have this circulation that's constantly occurring. Now, the question is, why does warm air rise? Usually that's something that we all know, but why is it that warm air is rising? Well, think about if you get hot. If you are really hot, you don't want to be really close to people. You don't want people all up on your business, so you want to spread out. Air molecules are the same way. So if you have warm air, these air molecules are going to spread out really far. And what I'm drawing are representative of little hot air molecules. So they are all really spread out because they're hot. They don't want to be near people. Okay, now think about when you get cold. When you get really cold, you want to be close to people. You want to cuddle. And so air does the same thing. So here are the same air molecules when they're cold. They're really close together. They're cuddling because they are so cold. Okay, so when air is warm, it spreads out. And when air is cold, it cuddles and it condenses and gets really close together. Well, the reason the warm air that has spread out is going to rise is because when it's spread out, it's less dense. Remember when we talked about density? It's how much stuff is in a unit of space. So if I take a unit of space of these two air samples, let's say it's about this size, there's only like one little warm air molecule. If I do a same size sample of the cold air, there's a lot more stuff within it. So because all the molecules are so close, there's more stuff, more gas within a smaller area of space. So that air is very dense, and therefore that air sinks. This air, there's less stuff in a particular area of space, and so it's less dense, so that air will rise. And that is a very, very important concept to understand to know convection. And as we continue with weather, that's something that you have got to know. Warm air expands, cold air condenses. And in fact, if I were you, I would write that down. Even though this is not on the slide, write down that warm air expands, cold air condenses. Meaning warm air gets further apart, making it less dense, therefore it rises, while cold air comes together, making it more dense, and therefore it sinks. So let's make sure we all get that written down. So I'll attempt to write it with this pen thing. So warm air expands equals less dense, so it rises, okay? Warm air expands, making it less dense, so it rises. Cold air condenses, equals more dense, and it sinks. Okay. I know that my handwriting looks absolutely beautiful as I write on the iPad for this, but make sure you know that warm air expands, so it's less dense and it rises. Cold air condenses, making it more dense, therefore it sinks. And again, I always think of the example of if you're cold, you cuddle. If you're hot, you spread out. Oop. And there it goes. Okay, moving right along. Oh, I do have a video of a floating bag that we'll come to the floating bag in just a second. First, I want you to think about this. Convection occurs in fluids, and yet we see that convection can occur in air, because we keep talking about air as my example. So is air a fluid? Well, yes, air is a fluid, and you don't have to write this down, but the definition of what a fluid is, this is a simple one, but it's something that can flow easily. Okay, if you have water, if you pour water from one cup to another cup, it can flow very, very easily. If you have a bucket of water, you can put your hand in it, and that water is going to move out of the way of your hand. Same with air. If you put your hands up in the air and you wave them around, it's not like you're walking into solid blocks of air and it's just stopping you. No, your hand can move through the air because the air is moving out of the way for you. Now, if you put your hand on your desk and you try to move your hand around in your desk, those molecules, because they're solid, they're not going to move. You're just going to hit your desk. So air is a fluid simply because it can flow easily. It doesn't have a fixed shape. And so therefore it's more fluid, it's moving. So whenever you think fluid, don't think liquid. Think fluid as being able to move. So liquid is a fluid and air is a fluid. Now that we have gone over what a fluid is, I have 2 videos that I want y'all to watch. The first video is going to be or it doesn't really matter the order, but the candle video. And then there's a video called I forgot what it's called, the floating bag. So the candle video and the floating bag, after you watch that, we will return to the notes and continue taking them. Okay, so in the floating bag video, you saw him put the bag over the hot plate, and because that air got hot, it was less dense, and so it rose. And the bag was over some of that air, so you could watch it rise. And then as soon as it got away from that heat source, as the air cooled, it came right back down. Now, the candle video is my favorite one. That one, all that's happening is you're mixing baking soda and vinegar, which we know that's also how you can make a volcano. And so as that combines, it creates carbon dioxide. That's all the gases. And carbon dioxide's a little bit more dense than the normal air that's around us. So what they're able to do is pour that air directly onto the flame to extinguish the flame. And that is simply showing you that air is fluid. You could pour water, you could pour air the same way. We just can't see the air moving, but it does move just like a liquid does. When you get home, feel free to try that candle video one. It took me a couple tries to actually get it to work, but it is really cool once you do have it, and you can impress your friends or family. So moving right along, radiation is our last heat transfer method. With radiation, you have transfer through electromagnetic waves. Everybody say electromagnetic. Okay, and I hope y'all actually said that, otherwise I'm going to feel kind of stupid. But electromagnetic waves that's the important word to remember for this, but you're going to have that basically from like sources of fire is really when you see it. So the sun has a lot of electromagnetic waves, and fire has electromagnetic waves as well, and so that is how that energy is transferred. So we do not get our energy through conduction from the sun, because that would mean that the sun was directly touching the earth. And if that happened, that would be very, very, very bad. Instead, we have the energy from the sun transferring to us through electromagnetic waves. Now, as that sunlight enters into the atmosphere and it heats the air through electromagnetic waves, it can then cause some convection to occur. So it can cause both, but it first enters through electromagnetic radiation, or just radiation, you could say, and then we can get some convection. And then as that air is actually touching the ground, that's going to transfer it through conduction. So that's how we can see all 3 transfer methods once the sun's energy reaches the atmosphere. So moving along, we have a couple more videos. So we already watched the floating bag. The magic ice and the drum crush is going to be in the more video. Those 3 are all conduction. So we're going to watch that, and then when you're done, we'll resume the video to continue. Okay, I hope you guys enjoyed those videos. So with the magic ice, the reason why the ice cube melted faster on the metal block was because, again, metal is a good conductor. and the heat transfer you saw was conduction. It melted much slower on the wooden block because wood is a poor conductor, and so it doesn't transfer that heat. It's not going to heat's not going to move as well from the block into the ice cube as it did when it was the metal one. Now, the Moore and the drum crush one, that's when you actually saw a soda can crush. And this is something that maybe when I get back we can do, but it's really neat when you have, so if you had a soda can that was closed and you did a lot of heat transfer, that could actually cause the can to bust. But because you are just working with one that's open, it's just showing you the movement of the air. So first you heat up the can, and when you heat up the can, it's causing the air within the can to get really, really hot. And so these air molecules are expanding, they're really spread out. Now, when you flip it over and put it inside ice cold water, those air molecules drastically collapse in and get really close together. Because they come in so quickly, that causes the actual can to crush. Now, I want you to think about something that occurs within weather that causes the air around you to get hot in a split second, and then it cools off immediately. In case you aren't thinking of the same along the same lines I'm thinking of lightning. So when you have a thunderstorm and you have a bolt of lightning, that makes the air get really, really, really hot very, very quick. It's like 4,000 degrees. And so all that air rapidly expands. Now, as soon as that lightning bolt is gone, that air gets colder, and so it starts to condense and comes inside. And as that air goes out because it's hot and then comes back in, it claps. And that clapping sound that you hear is thunder. So when you heard those cans, when they came in and then condensed in that the water, and they made that crushing noise, that is a smaller scale of thunder. So the air rapidly expands with the lightning bolt goes away, and the air comes in, and boom, that's thunder. So I just thought that was kind of a neat connection. But that shows you how these heat transfer methods are going to carry along with us as we continue on with weather.